Okay, so this is a gory word problem. And like I said, I think you have a homework problem that's like this. So we're going to start on I-35. I've got things in meters per second. We're going to start at exit 214. That's extraneous information. We don't necessarily have to know that. And we're traveling from a stop on the ramp, and it takes us 5 seconds to go from 0 meters per second to 27 meters per second to enter the traffic. We're going to travel at that rate for 30 minutes. I'm going to make sure that we have that as minutes. And at that point, we have to slow down to 15 meters per second for a construction zone. And it takes us 3 minutes to complete the slowdown. And then we travel 1,000 meters through the construction zone, where we return to our original velocity by accelerating at 5 meters per second. So I've just gotten some arbitrary numbers. This is probably going to be a little different. And we're going to travel another 5 kilometers before pulling off at the rest stop. And it's going to take us 2 minutes to slow from 27 meters per second to 0 meters per second. So what's the total distance traveled? What's the total time traveled? And what's the average velocity? So the first thing I would do when I'm looking at this is I'm going to draw this out into parts. So reading it again, we're traveling from a stop on the ramp, and it takes us 5 seconds to go from 0 to 27 meters per second. So we're going to start here with an initial velocity of 0. We're going to go to a new velocity of 27 meters per second. We know the time that it takes us to do this is 5 seconds, but we don't know the distance. So we're going to have to figure that out. So let's also write down our toolkit. Velocity final is equal to velocity initial plus acceleration times time. Velocity final squared is equal to velocity initial squared plus 2 times our acceleration times our change in distance. And we have our change in distance is equal to our initial velocity times time plus 1/2 the acceleration times time squared. Well, in this case, I've got time, but I don't have acceleration. I have my initial velocity and my final velocity, but I don't have distance. So I'm probably going to have to do this in 2 parts. So let's figure out my acceleration here. So we've done velocity final minus velocity initial divided by time is going to give me my acceleration. So I have 27 meters per second minus 0 divided by my time of 5 seconds. This is going to give me an acceleration. And so I've got 27 divided by 5. This gives me 5.4 meters per second squared. And now I want distance. So I'm going to use this equation here for my distance. So distance is going to equal my initial velocity is 0. So that part 0 plus 1/2 5.4 meters per second squared times my time of 5 seconds squared. That gives me meters, so I'm in good shape. So times 25 divided by 2. This gives me a distance of 67.5 meters. So now I've got this distance here is 67.5 meters. So I got my first part. So we took care of this. We know we're traveling. So we got that section of the problem done. So this is part 1. Now we're going to travel at that rate for 30 minutes before we have to start to slow. So we're going to go there. So this part 2 is we're going to travel for 30 minutes And 30 minutes is equal to 30 times 60 is equal to 1800 seconds. But we need to know the distance. And this one, we have no acceleration here. So the acceleration is equal to 0. So my distance is just going to be my velocity times time. And I'm now in the right units. So now I'm going to do my 27 meters per second times my time of 1800 seconds. That gives me a distance of 48,600 meters. So we've got the second part done. So now we have to slow to 15 meters per second, and it takes us 3 minutes to do that slowdown. So this is a deceleration for this one. So we're going to go from our 27 meters per second to 15 meters per second. Our time was 3 minutes, but we want that in seconds. So we got to figure that one out. That gives me 180 seconds. But we got to figure out our distance that took, because we need our total distance. Well, we need to know our deceleration. So we're going to use that same equation that we already did, except now our final velocity is 15 minus 27, because it's a deceleration and it's 180 seconds. So our deceleration gives us a negative 0.0667 meters per second squared. But we got to calculate our distance. Except now I do have an initial velocity. My initial velocity is 27 meters per second. My time is 180 seconds minus my 1/2 0.0667 times my 180 seconds squared. And this is in meters per second squared. So this time for this section, I had an initial velocity that I have to take into account. So I'm going to actually write out my numbers here. So I get, that's meters. This says it's going to be 3,780 meters. So now I have that number that I can put up here. Now we know this distance because we're actually given this distance. This distance, it says, now we travel at 100 meters or 1,000 meters through the zone. Okay. So now we're going to do that. So this distance is equal to 1,000. But now we need to know what the time is. Well, this time we're going to do distance is equal to velocity times time. Distance divided by velocity is going to equal our time. Our distance is 1,000 meters divided by our velocity, which was 15 meters per second. So our time for that section is 66.7 seconds. We're going to accelerate at 5 meters per second to get to our 27 meters. So this is 15 meters per second. And we're going to get to 27 meters per second. So we need to know time that it takes there. And we need to know distance, but this time we're given acceleration, and our acceleration is 5 meters per second squared. So our distance is going to equal our initial velocity, 15 meters per second, except I don't know time, so I got to figure out time. So let's go ahead and do this. We've got V final minus V initial divided by acceleration will give us time. So now I've got V final is 27 meters per second minus V initial is 15 meters per second divided by 5 meters per second squared. It says it takes us 2.4 seconds. So now I can put my 2.4 seconds there, plus 1/2 my 5 meters per second squared times my 2.4 seconds squared. That'll give us our distance. I'm going to square that times 5 times 0.5. This gives me 14.4. This gives me 36. Gives me 50.4 meters. So now we have this is 50.4 meters. Our time was 2.4 seconds. Then we travel another 5 kilometers before pulling off to a rest stop. So that one's an easy one. We've got 5,000 meters and we need to know time. So we're going to figure that one out. And that comes back to this distance divided by velocity is equal to time, except now we have 5,000 meters divided by 27 meters per second. Gives me 185 seconds. So we have our distance and our time. And then the last part is it's going to take us 2 minutes to slow down from 27 meters per second to 0 seconds. So we know I've got time is 120 seconds because 60 times 2 is 120. We only have to figure out our distance now. And that's going to get us back to the fact that we've got to deal with our acceleration. So I can put this one in here. And this time it's going to be a deceleration again. So we get this minus 27 meters per second divided by 120 seconds gives us an acceleration. Gives me 0.225. Now we've got to do our distance calculation one more time. Distance is going to be 27 meters per second times 120 seconds minus 1/2 or 0.225 meters per second squared times our 120 seconds squared. This gives us 3240 minus 1,620 gives us 1,620 meters. So I got 1,620 meters. So what we did is we figured out each individual step. We took the problem and we broke it out by each individual step. And we made documentation as to where we are, but we want to know the total distance traveled. So let's have our image here. So our total distance traveled is equal to that first part, which was 67.5 meters. The second part, which was 48,600 meters. The third part, which is 3780 meters. The fourth one was 1,000 meters. Then we have plus 50.7 or 50.4 meters plus 5,000 meters plus 1,620 meters gives us a total distance. We add all of those up. So I got 1,620 plus 5,000 plus 50.4 plus 1,000 plus 3,780 plus 4,860 plus 6,7.5. If I've got all those numbers added up correctly, I get 6,117.9 meters. We're going to do the same thing for time. Now, I think on your homework problem, you have a place where don't forget that your time that you stop, you have to add that in. So, but in our first part, we got 5 seconds plus 1,800 seconds plus 180 seconds plus 66.7 seconds plus 2.4 seconds plus 185 seconds plus 120 seconds. So I have all of those. So I'm going to add those together. And so now I get 2359.1 seconds, and I want my average velocity, which is going to equal my change in position divided by my change in time. And in this case, my average velocity is also going to be my total distance divided by my time. So now I'm going to get my 60.117.9 meters divided by my 2359.1 seconds. And it looks like our average is 25.5 meters per second. So this one kind of shows you a variety of one-dimensional motion problems all in one problem. Basically, what we did is we took it apart. We drew our picture to keep track of our various pieces. We broke it down, made sure we were in the right units everywhere. We ended up in meters per second. We didn't always have that. We also had to sometimes get our acceleration in order to get our pieces. And we made sure that we got all the different pieces before we actually calculated our final total distance traveled, our final total time traveled, and then our average velocity. Any questions before I stop recording on this particular problem? Like I said, I think you have a homework problem that's very, very similar.